Hello, and today's purpose of the day is I can find permutations and combinations. Please take some time to read the Why section in your textbook on page 764 and answer the following questions. The Why section is also right over at the right, and the three questions are listed below, and please have your answers ready to share out with the class. Permutations and combinations. The fundamental counting principle says that if two events can occur in m and n ways respectively, then the events following each other can occur in m times n ways. So an example of this would be an ice cream shop offers 1, 2, and 3 scoops of ice cream from among 12 different flavors. The ice cream can be served in a waffle cone, a sugar cone, or in a cup. Determine the number of choices possible. So I've highlighted a few of the important things here we need to look at. So we can have 1, 2, or 3 scoops of ice cream. So that's 3 different possible choices. We can have 12 different flavors. So I can write down 12. And then I can either have a waffle cone, sugar cone, or a cup. So that would be 3 different flavors. So I'm going to multiply the 3 different scoops of ice cream times the 12 different flavors times the 12 ways to serve that ice cream, which is a total of 108 different choices or different ways to order ice cream. So now let's take a look at what's called a permutation. A permutation is an arrangement of objects in a particular order. So an example would be, Miss Roddy will only have 7 players for her volleyball tournament this weekend. There are 7 positions on the volleyball court. In how many ways can Miss Roddy make her lineup? So if I have 7 spots to fill for this volleyball team, I know that if I have 7 players to choose from in that first spot on the court, I have 7 people to choose from. Then, when I look at the second spot, I've already used 1 person in that first spot, so now I only have 6 players left to choose from. And then I only have 5 left, and 4, and 3, then 2, and then 1 last person to fill that last position. So we're going to multiply these all together, and I end up getting, when I multiply them together, is 5,040 different lineups. So what we just did there is called a factorial, which means n exclamation point, the product of the positive integers less than or equal to 10. So here, the example that we did was 7 factorial, which was 7 times 6 times 5 times 4 times 3 times 2 times 1. On the calculator, you can actually use this by finding the factorial by clicking PRB and then scrolling over till you see the exclamation point. So please locate that on your calculator now. Let's look at another example. Next weekend, Miss Roddy will have all 10 of her players for her tournament. And how many ways can she make her lineup now? So now I have 10 spots to fill. Excuse me, I have 7 spots to fill, but I still have 10 players now to choose from. So in the first spot on the court, I can choose from 10 players. Then I can't choose that 1 player because they're already in a spot. So then I can choose 9 players, and then 8, 7, 6, 5, 4 different ways to choose. So now this is a little bit different because I have more players in which to choose from. So this will actually find, we could type this in our calculator now, 10 times 9 times 8 times 7 times 6 times 5 times 4. But this is known as a permutation, and we're going to use the formula for the permutation, which means permutation of n choose r, this is how we say that, part of the formula, is equal to n factorial over n minus r factorial, where n objects taken r at a time. So in my calculator, this will look like permutation of 10 choose 7, where here, or if I want to write out the formula first, this would look like 10 factorial over 10 minus 7 factorial, which here, if I write this all out, 10 factorial is 10 times 9 times 8 times 7 times 6, 5, 4, 3, 2, 1, over 10 minus 7 is 3, so over 3 times 2 times 1, and what cancels out is the 3, 2, and 1. So in my calculator, I would type this in, which is just what I got up here, or I could use that formula. So try that on your calculator now. Type in 10 and then hit the PRB button, and click the NPR. So I'll type in 10, then NPR, click enter, and then type in a 7. And you should get 604,800. The same thing we would have gotten if we had just typed in our calculator 10 times 9 times 8 times 7 times 6, 5, 4, and then that would give us our same answer as well. Let's look at another example. A designer has created 15 outfits and needs to select 10 for a fashion show. How many ways can the designer arrange the outfits? So this is a permutation of 15, choose 10, because once you choose an outfit, you can't choose it again. So therefore it's a permutation where this is 15 factorial over 15 minus 10 factorial. And again, try this in your calculator. Again, we would do 15 NPR 10, and then the answer that we get here is 1.09 times 10 to the 10th arrangements of outfits. Arrangements, we can say. Here's another one just to try. Make sure you're typing this into your calculator correctly. So permutation of 8, choose 3. Here I could even write out the formula, 8 factorial over 8 minus 3 factorial, or 8 NPR 3, which gives me 336. So again, practice using that button on your calculator. I really encourage you to find it so that it's a lot easier to solve these problems. Now we're going to take a look at a combination. A combination is a selection of objects in which order is not important. So whereas with permutation, order was important, now order is not important. So our first example we're going to look at is find all the combinations of A, B, and C in which order is not important. You want 2 letters together, but they need to be different letters. For example, AC is the same as CA. What are the choices you can come up with? You can come up with AB, AC, and BC. So there's only 3 different ways to write these 3 letters with 2 letters together, but being different letters. So the reason this is a combination now again is because, for example, AC and CA would be a repeat combination. So in order to take into account this, the combination formula is right over here, combination of n choose r is equal to n factorial over n minus r factorial, where this is n number of objects taken r at a time. And r factorial accounts for the repeat combination. So this was the little add-on here that was different than the permutation formula. So let's take a look at an example, a word problem, and see how this plays out. Louis is given the option of answering any 10 out of 12 questions on his history test. How many ways can he complete this test? So this is a combination here of 12, choose 10, and usually the bearer number is always written first. So here you have 12 questions and 10 to choose from, where 12 is n, r would be 10. So that's equal to 12 factorial over 12 minus 10 factorial, 10 factorial. So this is going to look like, I'm going to write this all out, is 12 times 11, 10, 9, 8, does not look like an 8. 8, 7, 6, 5, 4, 3, 2, and 1, all over 12 minus 10 factorial, that's 2. So that's going to be 2 times 1, and then I have 10 factorial. I'm going to actually move that over so I have enough room to fit all that in. So 2 times 1, and then you have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I wrote all that, that entire formula there. I've written that all out, and so let's see what cancels out. I obviously have the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1s cancel out, and then this 2 can cancel out with the 12 to become a 6. So 6 times 11 is 66 all over 1, so here is 66 different ways for Louis to complete his history test. Let's take a look at another example, and now we are going to use another button on our calculator to help us do this formula so that it's a little bit simpler for us to solve these problems. So example, the student council has 5 vacancies to fill with freshman students. 9 freshmen have applied to fill the vacancies. How many different groups of freshmen are possible? And again, these are all combination problems because order is not important. It does not matter how we choose the 5 student council members. It just matters that they're chosen, right? So here this would be a combination of 9 choose 5, where you have 9 factorial over 9 minus 5 factorial, 5 factorial, or on your calculator, go ahead and locate the PRB button, and where you see NCR, that stands for combination. So we want now a combination of 9 choose 5, so this is going to be 9, type in your calculator, NCR, and then type in 5, and you should get 126 different groups there of freshmen would be possible to fill the vacancies. Okay, now we're going to get into a couple examples where we have probability, so we have a little bit more coming into play rather than just using perhaps one formula to solve one of these types of word problems. So 21 chips out of 30 must be randomly selected. There are 12 blue chips, 8 orange chips, and 10 purple chips from which to choose. What is the probability that 7 of each color are selected? All right, I've done some color coding for you, so maybe it's a little bit easier to read. So let's think about this. We need to figure out the probability that we get 7 of each color selected. So we know we want our desired outcomes in the numerator, where with our total number of events in the denominator. That can happen. So here in the numerator, I want to choose 7 chips of each color. So right now I have 12 blue chips, and I want to choose 7. Does it matter the order I choose those 7? No, it doesn't matter. So that would be which type of formula do we want to use here? Do we want to use permutation or combination if order does not matter? Combination, you got it. So I'm going to say the combination of 12 chips, and I'm choosing 7 because again the order doesn't matter. I just want 7 colors, or excuse me, 7 chips of that color. Now I'm going to multiply that because now we want 2 at the same time to happen. We want 8 orange chips. Well, the 8 orange chips, we still want 7, and the order doesn't matter. So it's a combination of 8 choose 7. Then last, we want, out of the 10 purple chips, we want to pick out 7 again. So I'll say times the combination of 10 purple chips, choose 7. Now the total number of outcomes, and I color-coded that for you there, so hopefully that's easy to follow. The total number of events on the bottom is going to be a combination because it doesn't matter what the chips we choose in the order. It doesn't matter if we get 2 blue chips here, 2 orange there, 2 purple there. We just want to get the 7 of each color. So now it's a combination of the total amount of chips you have, which is 30, and how many are you choosing? Well, 7 of each color, but there's 3 different colors, so that would be 21 chips. So now this is what I need to type into my calculator, and I can certainly use the formula, the shortcut button that I know, and let's simplify this out. So combination of 12 choose 7 is 792, and double check that on your calculator. And the combination of 8 choose 7 is 8 times the combination of 10 choose 7 is 120. All over the combination of 30 choose 21 is 14,307,150. And this here then would be 760,320 all over 14,307,150. So for my answer, I get 0.0531, but we want the probability, so let's figure out that as a percentage. So we would get 5.31% given that many chips, that we would pick 7 of each color, which isn't that high of a probability because there's many different varieties that could happen if you want to choose, chips here with the 3 different colors and the total amount that there are. So here's a couple notes to help with figuring out if you have a permutation or combination. So the big question to ask is, does order matter? If order does matter, that's a permutation. So you're going to look for words in the word problem like left to right, first, second, third places, and arrangement of objects. That all means that order matters. If order doesn't matter, then you have a combination, and you're looking for words like grouping things or just selecting, because therefore it would not matter the order that you're selecting something. Thanks for listening. Please check Schoology for more information. Have a great day. Bye.